Good morning, people. Sorry we were delayed by around 15 minutes. I had informed you all that I had a Viva session of the first year BCom students. Sorry we were delayed by around 15. I'll just mute this thing here. I had a Viva session. Okay. Then Prathamesh, Karthik, Dhanraj, Sachin, Sanmit, and Bhavika, Vaishnavi. All of you all, a very good morning. Thank you for being patient and coming back at this time. Let us not waste much time and immediately go to continue what we were doing last time. And consequently, what I'll do is let me see if you're getting this. Yeah, we were doing this, and this is nothing but the geological time scale. By the way, somebody has answered this question on camels often sit down carefully, perhaps their joints creak persistently. Persistent early oiling might prevent permanent rheumatism. If you have worked on that, it's basically a, a short form of all these names that come, in the sense that yesterday we spoke about the fact that before we come back to this point, I'll just revise all that we had been doing yesterday. We said that the present age that we all believe that the earth is of is 4.6 billion years. Prior to that, there have been various methods by which geographers have tried, scientists have tried to measure the age of the earth, right from sedimentation along river channels or salinity of the oceans, radiocarbon dating of fossils. And then you have Kelvin, who starts speaking about the earth initially being molten and eventually it is cooling down. So he tried to measure it using the rate of cooling. And then some people spoke about the tidal force of the moon and so on and so forth. From the fact that in 1897 we believed that the earth was 90 million years old, you'll see that Kelvin took it to 100 million years old. And of course, then 1904, okay, Rutherford, he postulated that possibly the earth is not just millions of years old, it's billions of years old. And till 1950, we said that the consensus on the age of the earth was around 3 billion or 3,000 million years old. Presently, we say it's around 4,600 million years old or 4.6 billion years old. How do we measure this? We have divided this into various groups, but these groups are not geometrical or mathematical divisions. It is how and when we have found evidences of those very times that we have tried to place them one by one. And what we know about the earth is only a small portion. We know, as far as the history of the earth is concerned, we know around 10% of this. 90% of the time scale we are still assuming, and that 90% is basically divided into three parts. That is the Priscon or and the Archean. The Priscon is also called as the Hadean, wherein the surface of the earth was molten and it was slowly cooling down. You had meteors crashing on the surface, and at the same time we also had volcanoes erupting from the interior parts, and the whole surface was full of fire, etc. The temperatures were very high. The crust was still solidifying, we would say. It's only during the Archean period, which is say after the first half a billion years, that the some parts of the crust started solidifying, and so on and so forth. And life comes much later. In fact, for the first 1 billion years or so, we hardly had life on this particular planet. And in fact, even after that, when life came up, it was not immediately the larger size we had microorganisms, and the fossils of this particular period show that there is a possibility of life, and that is why you'll see that that period is called as proterozoic. That's towards life as such. So that is as far as life is concerned. I can just, yeah, you'll see that these periods here, the older ones, this is called as the Archean, right? The very old one. That's till around 2.5 billion years ago. And then you have proterozoic. Pro means towards life, that you can expect that you're going to have life in a few years, or few years, in the sense few millions of years or few hundred millions of years from there. Okay. However, you'll see that all of this three together is called as the Precambrian. The Precambrian is something that is before the Cambrian, and the Cambrian is going to be here. Okay. Now, what we have more details about is what happens after Precambrian. You'll see that the eras are divided into three forms of life. These three forms of life include the Paleozoic, that is very old form of life, Mesozoic, that is median form of life, and then there's Cenozoic, which is the modern form of life. Human beings belong to the modern form of life as such. Now remember, I had spoken about camels often sit down carefully, perhaps their joints. Now you take the first letter of all this, C, O, S, D, C, P, and let us apply it here. Okay, this is the sequence. Okay, camels often sit down carefully, perhaps their joints creak. Okay, and then it continues further. So this is a way, of course, students of BA would not be required to go into all those details, but uh, it is something of importance, particularly if you are say trying to specialize in geography one, if you're trying to take geography as your principal subject as far as your UPSC exams are concerned, then these things become important. Not that they are not of importance, but it would say that if a layman does not know these things, it hardly matters as such. Okay, now you'll see that the past 600 million years, it all composes of the Paleozoic era, and the Paleozoic era has six, so to say, periods. Okay, the oldest one is Cambrian, and if you remember, the one before that, before this is this part, the red column here, and that is all Precambrian, 90%. Now, how is it that we know a lot of this from here? Because larger forms of life, fossils of larger forms of life are found in this particular, from this particular period. You'll see that Cambrian to Devonian, we have life in water. It's only during the Carboniferous that you find water life coming up. But as far as the history of life is concerned, we'll come to that later. But we have to understand this in the terminology first. Okay, so the 7 year periods of the Paleozoic era are followed by, okay, all this is happening between, say, the 600 million years ago and let us say 3.5 million years, or sorry, 2.5 million years ago. Okay, at around 2.5 million years ago, we start having the Mesozoic period, and this Mesozoic period is comparatively smaller as compared to the Paleozoic. So the life was evolving, and the ones to evolve were reptiles, and reptiles grew very, very fast and very, very large during this particular period. So Triassic, Jurassic is the peak time, and then you have the Cretaceous, wherein they started going down. Now there are very many theories as far as these um, why the so to say the dinosaurs went extinct. Dinosaurs are nothing but very large sized reptiles as such. So that is what we have to remember here. Now, what happens during this particular period, say 100 million years ago, parallel here, okay, is that small forms of mammals start coming up. Now, mammals is the family to which we belong to. Of course, we were not there, but that is how it starts, all that starts happening. Then you'll see that this will be followed by what we are going to call as the Cenozoic. That's the modern. Okay, it's modern basically signifies mammals coming up to a larger extent, and this is divided into tertiary and quaternary. Okay, tertiary period and quaternary period. Now remember here that when you check the net for these informations, it may so happen that some scientists call these tertiary as eras. Okay, so instead of Cenozoic, they will call it as the tertiary era, and then you have the quaternary era. Now, why is it directly called tertiary? Why is it not called as primary? Possibly it because of the fact that scientists believe that very old form Paleozoic can be called as primary, Mesozoic can be called as secondary, and that is why then the first in the Cenozoic is tertiary, and the latter in the Cenozoic is called as quaternary also. Now you'll see that the sentence about camels, etc., it continues here. Okay, here we'll come to that again, but you'll see that of these, says so to say the last 60-65 million years, which make up the tertiary and quaternary. Okay, you'll see that this is how. Okay, Paleocene, Eocene. Now, if you want to remember this, okay, you'll see that a particular set is known by a particular say suffix to follow. Okay, now you'll see that as far as tertiary period is concerned, you'll see that Paleocene. Paleo necessarily means very old. So the oldest in that particular group is invariably called as Paleo. You'll see that. Okay, but you'll see that it is followed by the scene. So followed by Eocene. Then Cene is again common here. Cene is again common here. Miocene is common here. Pliocene is common here. The tertiary period ends with the Pliocene and then starts the quaternary period, which is a few thousand years ago only. And this is further divided into Pleistocene, and then you have the Holocene. Holocene is where man comes into picture, and so on and so forth. So this is a very broad thing. As I said, you don't have questions on this. You have very general questions. You don't have to go into the details, but I believe as students of geographers, we need to know this. Now, coming to remembering this and coming to this part of the diagram, we have been speaking about this. Okay, the nearest to us is evolution of human beings. I said quaternary, that too in the latter part. And then you have these tertiary periods, okay, wherein you have these um, animals, okay, similar to mammals. And then you go back into the Cretaceous, where you have all these fantastic types of dinosaurs. Okay, you see that you have flying birds during the Jurassic and so on and so forth. Now, coming to the geography of it, okay, you'll see that invariably it so happens that rocks during these periods are being divided into their own groups, in the sense that what we call as era in geological time scale is called as groups in rocks. Okay, the periods in geological time scale is called as the rock system. Then epochs in the geological time scale are called as series. Okay, you must have, I don't know whether you have read about the Indian geology. You'll see that the Kadapa system, the Vindhyan system, okay, the Damuda series, etc. All these are names of rocks which you find in and around India, and that is how we go about it. Okay, now going further, you'll see that by the way, as far as this sentence, camels like, often sit down. Do you know what this art of say evolving acronyms out of this is called as? Okay, if you can name me that, we'll come to that as well. You'll see that continental crust comes into formation way back, say around 4.5 million years ago. Okay, you'll see that by the Paleozoic time, the continents become very stable. They tend to get very hard. Okay, you'll see that you have they get so hard that you have erosion of these mountains and you have depositions of these mountains. Now, in your school days, if you have read about Alfred Wegener and his theory of continental drift, and he speaks about Pangaea, Panthalassa. This all happens towards this time, this period. That's the say the end of the Paleozoic. That's near the Carboniferous or the Permian. Carboniferous, by the way, another thing that I needed to tell you all is that it is during the Carboniferous that you have a lot of plant life. Okay, and you had these huge sized leaves, etc., on plants, etc. And thus, the best quality of coal that we mine today is dated back all the way to the Carboniferous period as such. Coming to the geological part, again, you'll see that this issue about Wegener and his continental drift starts near the Permian period. That's towards the last of the Paleozoic. And as we enter into the Triassic, you'll see that the continents are seen to be on the move, as it is called. Okay, you'll see that during the Mesozoic now, which is divided into three parts, you have reptiles, you have birds, you have small mammals. I did speak about it yesterday also. Towards the end of the Mesozoic, remember, towards the end of the Mesozoic, towards the Cretaceous, you'll see that the formation of the Himalayan ranges now starts. The formation of the Himalayan ranges now starts as such. Okay, and it all continues into the tertiary period also. You'll see that the Cenozoic period, in the Cenozoic era, by the way, this the modern one. I'll just enlarge it for you. The Cenozoic time. It's here that we start having, say, that the old animals, the older form of animals, are replaced by mammals, and mammals of very small size. In fact, it is said that during this particular period, when mammals were evolving, the average mammal was size of a bandicoot. Bandicoot basically means a large rat. Upon Marathi मध्ये त्याला goose म्हणतो. Okay, if the average mammal was of that particular size. If you see today, present day, the average size of the mammal has grown as large as a dog. As a dog, you'll see that dog is the average size representing mammals. Yes, we have larger animals in the form of elephants and whales, etc. But all that average together, it is not more than the size of a dog, which is a significant development of what happened at the start of the Cenozoic period, wherein average size mammals were size of a bandicoot as such. Okay, now you'll see that if we speak about this, the Miocene period and the Eocene, I'll just come out of this and we'll go into it again in a different way here, because I want you all to understand that as far as the Himalayas are concerned, you'll see that it starts very significantly growing into formations in the Eocene period, and then it's followed by the Oligocene and Miocene. And by the time you come to the Quaternary period, the smallest of the Himalayan ranges, if you have done this well in your geography, the Himalayas are basically three parallel mountain ranges: the Shivaliks, which is the youngest, then you have the mid Himalayas, and of course then you have the Himadri, the proper Himalayas as such. So the newer one is during the Pleistocene and the older one is during the Eocene. And we all know that it's the peninsular part of India which went into ramming into the Asian plate, as it is called. We'll be seeing what plates are. And all the sediments that were there between them, that's in the Sea of Tethys, they rolled up into the Himalayas. It was a gradual period. And why can we say it's a gradual thing? The Himalayas didn't come up suddenly. You'll see that these are minute things in geography that you need to understand. If you see the rivers like the Brahmaputra and the Ganga and the Yamuna and the Indus as well, you'll see that all these rivers, they rise beyond the Himalayas, but they cut through the Himalayas to come to the southern part of the Himalayas. This indicates, now, if the Himalayas would have come suddenly up, the Ganga, the Brahmaputra, and the Indus would have locked themselves there. But because they came up very slowly, they kept on passing through. The rivers kept on passing through. They kept on cutting through, and that is why they could come all the way to this. And that is why you have the Indus plain, you have the Brahmaputra plain, and of course you have the Ganga plain also. So this is an interesting development, that the Himalayas came up very, very slowly. And in fact, it is believed that the formation of the Himalayas is still not complete. If you see the latest height, now of course, India has its own methods of calculating the height. The Chinese have in fact projected their own height. But for a significant period, when I was in school, we used to write the height of the Himalayas as 8,848 meters. But of late, if you see check the net, you'll see that they have revised this height. Now, whether it has risen or whether it is a revision calculation of height, that needs to be debated. But presently, you'll see that it's 8,850 meters high. So you'll see that different scientists calculate the height of Mount Everest in different ways. Now, if you come down south, okay, you have the Deccan Plateau, the peninsula as it is called. And it's very interesting to note that all of us should be very proud of the fact that we live in a country which has a very fantastic, so to say, the very fantastic geological history. You'll see that presently where we are, all those who are in Maharashtra and south of Maharashtra, we are living on a surface which is very, 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 very old. In fact, this piece is one of the earliest of the piece to have come up in the form of solid. All that solidifying that took place as far as the crust is concerned. The peninsular part of India is that old. In fact, uh, of course, over that you have the lava. That's the Deccan Plateau as such, but the peninsular part is very, very old. And besides Indian peninsula, you'll see that you have what is called as the Canadian shield, you have the Brazilian shield, you have the African shield, you have the Siberian shield, and you have the Australian shield. These are the smaller pieces of land which came up first, and the present land has grown around it. Okay, so India, as a matter of fact, has the youngest mountains in the world. That's the Himalayas, which are not more than 60 to 70 million years. And then you have very, very old rocks in the form of peninsula, and above that now you have the Deccan Plateau, and in between them you have the Gangetic deposits, the Gangetic plains, which is very, very modern. So within India you have rocks which are billions of years old. We have rocks which could be a few hundred years old also. So that's very fantastic information that we need to keep in mind, that we are lucky enough to be in that part of the world wherein you have a variety of rocks, from very, very old rocks to very, very new rocks all around us. Now, there is one more concept that we need to understand, and for that we need to go to the next slide. But before that, I'll just introduce a few things that uh, the peninsular part of India, and above that you have this volcanoes that erupted, and then the formation of the Sahyadris as such. Now, how and when did the Sahyadris come into being? Okay, they are not as old as peninsular part of India. So the Sahyadris are up, and the peninsula is low. So you had the Sahyadris which went into formation, and now they sit over that. Okay, so these are the Sahyadris. This is the Arabian Sea side, and this is of course the eastern part of Maharashtra, if we are speaking only about the Maharashtra as such. So this is very old, this is semi-old, and then above this Himalayas we are going to have young, and then the deposits of the Ganga are younger than that. So when did the Sahyadris form? Okay, and how did the Sahyadris form? There is a very interesting story that goes along with this, and for that we need to discuss all about this. Okay, there is something which is called as hotspots. Okay, now when you search for hotspots on Google, you'll have to type hotspots geological. Okay, so you'll get these diagrams in front of you. Now, what is this? Let us start looking into them one by one. Okay, you would remember that as far as the Indian peninsula, which is here, this is the Indian peninsula. It started way down here. Okay, if you can see my hand, the cursor here, it started way down here, and it's kept on moving north, 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 north. And if you can read this Reunion, okay, just off the coast of Madagascar, you have Reunion Island, and you have this large blot here. Now this is where you have the hotspot which created the Sahyadris. So it was like when it was flowing, okay, the Indian plate was flowing above the Reunion Islands. You had the volcanoes which came out of this. Okay, the volcanoes came up, and they kept on coming, kept on coming, kept on coming, and the whole stretch of the Sahyadris went into formation. And it is not only this one. You'll see that you have so many hotspots in different parts of the world. Some of these are still active, some of these are defunct now. But if you remember the movie 2012, I think it is, yeah, 2012, which comes on Star Movies, it speaks about the Yellowstone. Okay, if you are tracing my hand here, the western part of the United States of America, you have the Yellowstone National Park, and the Yellowstone is sitting on hotspots. This is possibly one of the very few areas wherein you have hotspots, or you have land which is above hotspots as such. Similarly, you'll see that if we speak about the Hawaii hotspot, it's a very interesting thing, and I'm going to come to the story of that also. Then you have the Kerguelen hotspot also. You have many, 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 many hotspots in different parts. Now, what exactly are hotspots? Okay, you'll see that these are places where you have active volcanoes below. Okay, here. Okay, so here somewhere you have core, and you have a plume of very hot lava that comes up and it rises through the mantle. And while it rises, it takes this particular shape. Okay, this is called as the head of the shape. It is still coming up, 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 and it's still rising, and it has a tail, and you'll see that it breaks through the lithosphere, and then you'll have the flood basalts which come up, flood basalts. Okay, now the plate here, the lithospheric plate is moving from, say, your right to your left, and while it moves, you'll see that it evolves what is called as a volcanic trail. Now, what is this volcanic trail? This plume which has, and let me tell you, this will take a few thousands of years at least, if not a few million years, and it will continue for a few thousands of years as such. Now, as far as this volcanic trail is concerned, let us understand it in an interesting way. I'll just show you that here now, okay, this plume has come up here, and let us say it is below the Pacific, and the Pacific plate is moving. So you'll see that the present Hawaii is here, and this is the oldest of the Hawaiian islands. So you'll see that the plate is had kept on moving, 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 and the volcano kept on coming up, coming up, coming up. So you'll see that you'll have these 1, 2, 3, 4, 5. मराठी मध्ये आपण त्याला सांडगे टाकणं म्हणतो. Okay, so these islands are like they have been dropped one by one, one by one. Of course, they are not dropped. You see that they have evolved out of this volcanic eruption that has come from the Hawaiian hotspot. Okay, so this is how these volcanoes come up, and actually what happens with in that reference can be seen here also. You'll see that you have these convectional currents on land surfaces. This is how it will come up, and as far as water surfaces, this is how it will come up. Now, normally when it comes up on land, you have it's less dense, and that is why you have granite on land, which is less dense. On the other hand, at the base of oceans, okay, it's denser, and you have basalt. So of the two igneous rocks, basalt and granite is lighter, and that is why you'll see that continents float not in the literal sense, but because they are less dense, they sit on basalt, which is denser. Okay, and then you'll see that how these plates move at one particular end. They say when the plates will collide, one of the heavier plates. Now, because this is basalt, this is heavy, this is land, this is granite. So you'll see that the continents will stay up and the basalt will go down. As it goes down, the pressure will obviously cause it to melt, and this melt will form new plumes of lava, and these lavas will once again come up on the surface in the form of volcanoes as such. Of course, I've explained it very fast, basically because we need to do it again when we're going to speak about the plate tectonic theory as such. Okay, so this is an interesting aspect that we need to remember, that the Sahyadris are basically formed. And in fact, one more thing that I needed to tell you all about the Sahyadris is that if you have noticed that the western part of the Sahyadri, the western edge of the Sahyadri is very, very steep. It is believed that this part, Madagascar, if you pull this or you cut Madagascar and you try to place it next to this is the western coast of India. Some scientists believe that they match each other. And in fact, what happened is when the Sahyadris went into formation, one part of it moved ahead and Madagascar moved westward, and it is there where it is today, while the Indian plate kept on moving. And here is where you have India presently placed as such. Now, the Maldives, etc., or even say the Mauritius Islands are all an output of the volcano that is being poured out of the Reunion Islands as such. So this is another information that I wanted to share with you all. You have to think on this, okay, so that you tend to get into detail understandings of what actually is happening around us. And of course, the speed at which this takes place has to be measured on the geological time scale. Okay, it takes thousands and millions and at times billions of years also. Now, if I am to put all this into an understandable scale, okay, when we think about millions and billions of years, it tends to be very confusing, isn't it? And that is why we need to understand this in a more understandable way. And scientists have helped us to come up with that. And you'll see that here there are two scales. Okay, if we are putting it in on a clock particularly, if we take a 24-hour clock, it's very interesting to note that if the formation of the earth takes place at 12 o'clock midnight, what happens? In fact, till 3 o'clock in the morning, That's what significant part, a quarter of the half hours, that the meteorite bombardment kept on taking place. Okay, so the first 1 billion year, okay, a complete 1 billion year, this keeps on happening. It's around 4 o'clock in the morning that this is a 24-hour clock. Let me tell you, this is not a 2 hour clock. This is a 20. This is not a 12-hour clock. This is a 24-hour clock. So around 4 o'clock, origins of life, in of course in a very microscopic form, start coming up. The oldest fossils traced of today. Okay, we still don't have fossils from here, but we have fossils of the time around 6 a.m. I would say 6 a.m. Okay, so you'll see that till 6 a.m. in the morning, hardly anything is happening. Let us go into what happens after 6 a.m. here. Okay, so you'll see that you have abundant banded iron formations. Now we'll go into these details when we look into, or when we have time, and when we go into what can be called as the how that documentary I told you. When we go into that documentary, you'll understand this. But you'll see that it's only at around noon time or after noon time, say 1:30, 2 o'clock, that single cell algae are found around 2 o'clock here. Okay, and you'll see that all this keeps on happening. Now just imagine that life has started 2 o'clock. The Earth comes into formation 12 o'clock night, and nothing has happened till morning. Nothing has happened till noon. It's only post noon that single celled animals come, and 6 p.m. in the evening now sexual reproduction starts. That's flowering plants, etc., start coming in towards that particular period. And you'll see that major activities start happening only after that, and that is why you'll see that major traces of life are found in the last 600 million years. But again, you'll see that it's very interesting that when it comes to jellyfishes, etc., seaweeds, they happen to come up around 8 o'clock in the night. Trilobites, etc., fossils, 9 o'clock. So you'll see that the whole day is literally gone. Nobody's speaking about larger animals, etc., etc. You'll see that land plants come around 10 o'clock in the night. You always have to keep in mind that, like, the earth starts formation, or earth is formed at 12 o'clock midnight. The whole morning has gone, afternoon has gone, literally evening also has gone. We have 9 o'clock in the night, and you'll see you have jellyfishes, etc., etc. Land plants come at around 10 o'clock. Coal swamps, that is carboniferous period that we can relate to, happens around 10:30. Dinosaurs, see, you'll see that normally we speak about dinosaurs being very, very old, very, very old, very, very old. But on a 24-hour clock, just see at what time dinosaurs were formed. Nearly 11 o'clock in the night, nearly 11 o'clock. So the day, it's hardly 1 hour to finish the day, and it's towards that time that dinosaurs come. Mammals come into formation beyond that, 11:40. And in fact, you'll see that human beings, okay, it's just 2 minutes or in 1.5 minutes for the day to end, and human beings arrive at 11 hours and 58 minutes and 43 seconds only. So you can just imagine that when we say that man is strong, man is this, man is that, man is this and that, you see that we have not been on this planet for not more than 1.5 minute. In fact, even it's nearly only 1 minute as such. Okay, so this is in short the whole history of the Earth, the geological history of the Earth, put on a 24-hour scale. There's one more scale which would be interesting to be studied here, and it is this. Okay, that if we say that 1 second was around 1 lakh years, then how does this look? 1 second was 1 lakh years. See how does this look? It's very similar to earlier one, but it's very funny to understand this also. You'll see that the quaternary era, okay, is just 17 seconds of this, and it's towards the latter part that you have camels often sit down carefully. That all things starts in the last quarter only. Okay, Mesozoic era here is towards the end here. So this is an interesting aspect again to know. And yeah, we spoke about this, okay, and I told you all to check this. Mnemonics is the word. Mnemonics. M is silent. Mnemonics is basically the art of compressing something which is difficult to understand, taking some representation from there and forming a new sentence so that it can help you understand or keep this in mind as such. So this is as far as the geological time scale is concerned. I'll just come out of this and let us have some other discussions also. And yeah, okay, let me see what questions you have put for me. Mayuresh Kumar says Trans-Himalayas. Trans-Himalayas are not a part of India. You'll see that the Kailash mountain, for example, is in Trans-Himalayas. Yes, he has written the height of the Mount Everest 8,850. He further asks that Indian Peninsula is a shield. Yes, the Indian Peninsula is also a shield. It's one of the smallest of the shields. And let me also tell you that the speed with which the peninsula moved, it was way down somewhere near Antarctica, present Antarctica, north of Antarctica, let us say, somewhere between where South Africa is today and Antarctica is. And it has moved literally, geologists believe that it moved at a speed of 16 to 17 centimeters every year, and this is very very fast. Even the present speed, let me tell you, if you know where Iceland is in the Atlantic Ocean. It's only where, and it's the margin of what is called as the European shield and the North American shield. It's in Iceland that you can see these two plates or shield plates, tectonic plates. They are spreading away from each other at a speed of 4 to 5 centimeters only. This is considered to be very fast today, but you'll see that the Indian peninsula moved at a speed of 16 to 17 centimeters per year. That's a very interesting thing to note. It was possibly because of the size being very small, it could move very very fast. But interestingly, from southern hemisphere crossing the, so to say, the equator, coming towards the north, and in fact heading into the, so to say, the Eurasian plate, the European Asian plate, and then banging into it. And it is believed that a significant part of it has now gone down, and what lied in between them has led to the formation of the Himalayan ranges. It is also believed that there is most of these ranges have come up from a fault, and it is believed that to the south of the Shivaliks we have another fault which has come up. Geologists say that, and possibly in a few million, hundreds of millions of years from now, you could have a fourth parallel range. This is all hypothecation, we don't know, but you could have fourth. So say 1,000 million years from now, you could be saying that the Himalayas are four parallel ranges rather than three parallel ranges. Of course, all this is speculation and hypothecation. We don't know how fair this would actually be going into, because possibly we will not be there. We, in the sense, human beings, will not be there. The rate at which we are harming the environment, the problems that we are facing, we could go extinct way faster than nature allowing them. Now remember that howsoever we try, okay, you'll see that uh, the dinosaurs at some point of time, they literally dominated the whole earth, isn't it? But even they went off because of that meteorite which struck the earth, and all that happened after that. We'll be doing that when we speak about the, the the plate tectonics then. So it's very uh, scary to know that yes, human beings will not be on this planet. But remember that we have been on this planet for a few seconds. We just saw this. Okay, though we have a very long history, but it may be possible that not only human beings but all the animals on this planet, all life on this planet, may go extinct before the Earth becomes a very barren planet, and then at the end of the life of the sun will go into being a black hole, and the whole solar system possibly would be sucked into this black hole as such. Okay, you can read a lot about this on um, the internet also. Just that you need to type the right questions as such. Well, that is all we had for today. Next time when we meet, that's of course tomorrow, we'll take up a new topic and let us see what that topic is going to be. We'll stop here today. Until we meet tomorrow, stay home, stay safe. I would be ending my broadcast